Hello, this is Debarshi Kundu again. In this tutorial I will cover patterns and conjectures. So first things first, what is a pattern? A pattern is a repetitive sequence of elements. To find the next element in a pattern, you use inductive reasoning by inspecting the previous elements in the pattern and predicting the next one. There are two types of patterns: arithmetic series and symbolic patterns. Arithmetic series are a series of numbers that follow a certain pattern. I will now show a computer program that I created in Java that inputs the number of odd numbers to display and outputs that many every 2000 milliseconds. If you want to learn the source code to this computer program, I will show you how to make it in one of my future Java programming tutorials. The output is an arithmetic series, as the odd numbers printed are all one number apart from each other, starting with the number 1. Let's just inspect the code here for 1 second. Okay. So now let's build and run this piece of code. As you can see, it asks me enter the number of odd numbers that you want to print. I'll put 10. Starts with 1, a 3, then a 5, then a 7, then a 9, then an 11, 13, 15, 17, 19, and then it ends, because those are the first 10 odd numbers. Now, the interesting thing is, how do we call this an arithmetic series? The reason is because each number is spaced apart by one number. For example, 1 is one number away from 3. 3 is one number away from 5. There's only one number in between that number and the number after that. So, yeah, that's how it's an arithmetic series. Symbolic patterns are a repetitive sequence of shapes and figures. An example of a symbolic pattern is shown here in this picture. As you can see, the pattern starts with a circle, a hexagon, a right arrow, a left arrow, and another circle. Now suppose that we were asked for the next figure in the pattern. What would you do? The answer, my friend, is inductive reasoning. We would study how the pattern works, its previous elements. Then we would determine what comes next in the pattern. In this picture, we can all tell that the next figure will probably be a hexagon. The next things that we will work on are conjectures. A conjecture is a prediction based on inductive reasoning. Conjectures are often written as conditional statements. Conditional statements are statements in the form of a hypothesis, which, by the way, is an if-then statement. Not all conditional statements are true. An element that disproves a conditional statement is called a counterexample. The conditional if a four-sided figure has all angles congruent, then the figure's sides are all congruent is false. A counterexample for the conditional would be a rectangle, since not all rectangles have 4 congruent sides, but all rectangles have 4 right 90-degree angles. The inverse of this conditional statement would negate both the hypothesis and the conclusion of the statement. So the inverse of this conditional statement would be if a four-sided figure does not have congruent angles, then its sides are not congruent. Which is false, because a rhombus has 4 congruent sides, but not necessarily 4 congruent angles. The converse of a statement switches the hypothesis and the conclusion. If a figure's sides are congruent, then the figure's angles are congruent. That is the converse of our original conditional statement. The contrapositive switches the hypothesis and the conclusion and negates them both. If a four-sided figure sides are not congruent, then the figure's angles are not congruent. Before I finish this lecture, I would like to show you how conditional statements apply to the real world by creating a computer program in Java. This will ultimately show how much in common geometry has with computer science. X this out for a sec. As you can see here, we've got the coding right here. So what we've got here is an integer x, which is initialized to 0. This is an if-then statement, but where's the then? The then is covered by the braces. If x is greater than 0, the computer will output hello world to the screen. If x is equal to 0, the computer will output goodbye world to the screen. So, let's build the project. The result is goodbye world. Why? Well, originally x was initialized to 0. So, since we put if x is greater than 0, then print out hello world, it's not going to do that, because x is equal to 0. It's not greater than 0, it's not less than 0. It is 0. So then I put if x equals 0, print out goodbye world. So since x is actually equal to 0, as it's initialized right here, it's going to print out goodbye world. And I emphasize that computer science and geometry are very alike. Computer science and mathematics in general are very alike. Logical reasoning. And that's why I like to include computers into my curriculum, because kids like computers, and I believe that in the next 20 years technology will improve so much, and I believe that it's important that we involve technology in our curriculum, no matter if it's math, science, history, or whatever. Thank you for your time. This is Debarshi Kundu, signing off. Please attend my next lecture.